Hello fellow problem solvers, so today we're going to be doing another set of problems from number theory. Namely, now it's going to be around divisibility. This is from Engel's problem solving strategies, the chapter on number theory, problem number 3, the problem sections. I invite you to try all of these problems out for a minimum of 5 minutes, ideally 15 minutes in total, but not more than 45 minutes in total. If on the other hand you'd like to go along with us, try part A for a minute, part B for 2 minutes, part C for 2 minutes. And now let's begin. So part A says we need to prove that 6 divides n to the third plus 5n. Now how can we deal with this? To show that means that there always exists a number t such that 6t is n cubed plus 5n. That's one way of looking at these things. Another way is to look at, okay, what does this mean? Well, I can factor this as n times n squared plus 5 modulo 6. And what I need to do to prove something is divisible by 6, it needs to be divisible by 2. And 3, is this divisible by 2? How can I prove that? Well, I can say, look at the cases. If 2 divides n, then 2 divides n times n squared plus 5. If 2 doesn't divide n, that implies n is of the form 2l plus 1 for some l, and then n squared plus 5 is 2l plus 1 squared plus 5, and then this is equal to 4l squared plus 4l plus 6, which is 2 times 2l squared plus 2l plus 3, and this is divisible by 2. So in both instances, we have that 2 divides this. On the other hand, for 3, if 3 divides n, then we have that the whole thing, then 3 divides n times n squared plus 5. And if 3 doesn't divide n, then n is of the form 3t plus n minus 1 for some t. It's either going to be plus 1 or minus 1 for those that haven't seen this sign before. And now what is n squared? Now n times n squared plus 5 is going to be 3t plus or minus 1 times, this is going to be 9t squared plus or minus 6t, and then it's going to be plus 1 plus 5 plus 6, and this is going to be equal to 3t plus or minus 1. Here we can take the 3 out, so this is going to be times 3 times 3t squared plus or minus 2t plus 2. And now this is divisible by 3 because it has a 3 times something. And now we've proved part A. This is one way of doing it, looking at cases. Another way of doing it, and here's what actually we've been looking at, is the possible remainders when divided by 3 or divided by 2. And we showed that no matter what the remainder, the whole number will be divisible by 6. Now there's a different way of solving this. 6 divides this, and this is true if and only if, so if A divides B, we're using this rule now, A divides B, if and only if A divides B plus or minus A times K, right? So if A divides, like how do we prove this? If A divides B, there exists an L such that AL is B. And then we have to show that this divides this, then AL plus or minus K is equal to B plus or minus A times K. So then this is true. On the other hand, if this is true, if L is B plus or minus AK, then B is going to be equal to A times L minus plus K. So both cases are true. And this is something we use when trying to solve these divisibility problems, especially at the introductory level. So now this is true if and only if we subtract 6n, if and only if n divides n cubed minus n, right? And why do I subtract this? Because this is much nicer to factor. In fact, this is n times n squared minus 1. And now do you recognize this? Well, it's a difference of squares. And this is equal to n times n minus 1 times n plus 1. And we need to show that 6 divides this. And now the argument is, these are 3 consecutive integers. That means one of them will be divisible by 3, and at least one of them will be even, because they're consecutive. And then this solves part A. Now let's move on to part B. So we need to prove that this is true. Now, what is this equal to? Well, this is, let's factor it. This is n times n to the fourth minus 1. What is this? Well, you can look at this as n times n squared squared. The squares multiply out minus 1, which is then equal to n times n squared plus 1. This is like 1 squared, n squared minus 1, which is then equal to n times n minus 1, n plus 1, and n squared plus 1. And we need to show that 30 divides this. Now again, what are the factors of 30? They're 2, 3, and 5. We have 2 and 3 just from this here, like the similar argument we did before. Now we need to show that 5 divides this number. Now, of course, if n is of the 4, like now we're looking at the possible remainders. We're looking at all the possible cases to show that this is actually the case. So now, if n is of the form 5 times k, or 5 times k plus or minus 1, then 5 divides one of these 3 numbers. And this sort of thing is a general sort of problem-solving meta rule, like a general strategy to think about is, I want to show something is the case. In which subcases of n here am I done? And I'm done in these subcases. And then I'm left with 2 cases. N is 5k plus or minus 2 for some integer k. And now we know that 5 isn't going to divide this, this, or this. So what? 5 will have to divide this. So let's look at for n is 5k plus or minus 2. What does this turn into? Well, n squared plus 1 is going to be 5k plus or minus 2 squared plus 1, which is going to be 25k squared plus or minus 2 times 5 times 2, which is 20k plus 4 plus 1, which is going to be 5 times 5k squared plus or minus 4k plus 1. And now this number is divisible by 5, so again, we are done. And I'm using plus or minus 2 also, just so I get rid of 2 cases at the same time. And I'm doing this, to be fair, because I have prior knowledge. I've seen these problems before. But this is a technique. You can do them separately. And you might ask, what about 5k plus 3? Well, 5k plus 3, if you can write this as 5k plus 1 minus 2, right? Because it's going to be 5 times k plus 5 minus 2, which is 3. So this is just like another k, in this case right here, and you get minus 2, like it's the same sort of remainder. So if you think about remainders are usually positive, but you can also look at them as negative. You know, like a remainder of 3 is same as a remainder of negative 2 when you're dividing by 5. It's just like a little thought pattern to have. And now we move on to part C. So part C asks, for which n does 120 divide this? Now what is 120? Well, that's 8 times 3 times 5, right? That was 30 times 4. So we know that 3 and 5 are always going to divide because it's the same thing we had before. N plus 1 and n squared plus 1. So the question is, when does 8 divide this? And now there's a bunch of cases to be thought of, right? So actually there's not so many cases because we're looking at parity things. What happens if n is odd? Like it's either odd or even. If it's odd, then this is divisible by 2, this is divisible by 2, and so is this. Because if n is odd, then n squared is odd, and then n squared plus 1 is even. So every one of these is divisible by 2, which means their product is divisible by 2 times 2 times 2, which is 8. So if n is odd, then great, we're done. Now what if n is even? Then 8 doesn't divide this, doesn't divide this, doesn't divide this, because all of them are odd. It's an even plus an odd number, which is what? An odd. Now we then need 8 to divide n. And if 8 divides n, then we're done. So that gives us like all the solutions. So for n, so the actual answer is for n that is divisible by 8. How are we going to write this? For 8 divides n, or 2 doesn't divide n, we have that 120 divides n to the 5th minus n. And now with this, I hope I showed you a couple of different thinking strategies for number theory, and we're going to continue in the next part of our number theory course. So now, as always, thanks for problem solving.